Konnichiwa, my name is Asman Samasi and welcome to day 5 of the 100 days of deep learning practice session. Okay, in this video we are going to practice our optimizer and our loss function. Okay, so here basically, as always, if you don't understand anything, you could check the lecture or search on the internet or ChatGPT and solve 5 problems of this same type to stick it into your mind, or as an optional do 5 push-up as in punishment. Okay, so let's start. Also the answer you could get by clicking on this link to get all the answers. Okay, for now let's start. Okay, first we must import our torch and our torch dot and our import torch dot neural network as nn. Okay, then we have to also import our torch dot optim optim as optim. Okay, so here we import our torch function. Okay, so first question we have here is that we have a regression problem where we have to create a class net a here, which will take from nn.module and the first function we have here is our /init// which take our self and it calls our first super dot init// and then we have to create one linearly. So we will write it as cell dot f1 equals to nn dot linear, which is going from 10 to 1. Okay, you could see here that the one value is coming at the last, specifying it's an linear regression problem. Okay, then we make our forward function here, which will take our self and x here, and then we return our f1 passing x function. Okay, I must return it as it is, and then I initialize my class. So model equals to net a, then our loss equals to, it's saying we have to use our MSME loss, so we do write here MSME loss, and then our optimizer as our optim dot adam. Okay, we passed here model parameters, model dot parameters, and our learning rate should be our 0.001. okay, so finally we specify here all the condition. Okay, and so our answer will match our this function. Okay, we have our spell dot as it is. Okay, so here first question is clear. Okay, then we have our netb class with our netb we have, which will take our nn module. We have our first init here, which will be getting self here, then our super /init// then we have here first we have here is that linear layer. Okay, so self dot f1 equals to nn dot linear, that is going from 5 to 20. Then we have here ReLU which is our nn dot ReLU. Then we have here linear only, and since it is ending with our 1 as an output here, it means it's an linear problem. Okay, I mean regression problem. So 20 to 1. Then we have our forward function, which take our self and x here, and here we pass this one by one. Okay, so we will first with our f1, then we will pass with our ReLU, then we pass it with our f2, and then we return the x. Finally we initialize our model to our netb here. We make our loss function as what it is, L1 loss. Okay, our mean absolute error loss function. Then we have our optimizer as our optim dot, what is the optimizer here, SGD. Okay, SGD optimizer. We pass here our model dot parameters, and then in our learning rate we pass it as 0.01. okay, here you will see that method object is not iterable. I think I done something wrong here. Okay, here I forget to add this. Okay, bracket here, model parameters here, and here also I added it. Yes, so finally we get this answer. Okay, then our in netc we need to create a new class here named netc. We take from our nn module, then we make our init that will take self here, and then we call our super class first, then we define our self dot sequence layer. Okay, I am using sequential layer directly to pass through the whole function here. Okay, 8 to 16. Then we have here nn dot tan h, and then we have here nn dot linear, that is going from 16 to 1. Okay, since it is going from 16 to 1, it's an regression problem. Okay, here we take our self and x, and we return our self dot sequential full. Okay, we then initialize our model as netc, then we make our loss as our smooth L1 loss. Okay, our hyper loss. Then we have here optimizer as RMS propagation. We will first pass here our model parameters, learning rate equals to 0.0005. so here it will tan h. I done anything wrong here? Oh sorry, tan h. Smooth L1 loss. Did I do anything wrong? SMOOTH. Wait here just a second. Smooth L1 loss. NN dot smooth L1 loss. Okay. Here I forget the NN. Okay. RMS propagation. Okay. I forgetting to do this thing. Okay. So finally work mean it's finished. Okay. Now we have here regression problem with our net D. Okay. Class net D, which take our NN module, which our first have our init here, which will take our self. Then we have our super to initialize our super class. Then we make here our sequential layer, self dot sequential, which will take our first going from linear 3 to 6. Then we have our ReLU here, ReLU activation function. Then our linear again, that is going from 6 to 6. Then our ReLU again, and then finally our linear. Okay, since it is ending by 1, it's an regression problem. Okay, then we have our forward function here. We takes our self and x, and we will be returning our sequential layer. Okay, so self dot sequential layer, and we return it. Okay, then we initialize our model net D. Then we initialize our MSE loss. Then we have our optimizer as SGD. Okay, SGD with momentum. Okay, so we write optim dot SGD with our model parameters, with learning rate equals to 0.01 and momentum equals to 0.9. Okay, where the sequential. Okay, here it will be NN dot sequential. Okay, so here finally you also get to understand how to use the SGD with our momentum. Okay, then we have our binary classification with our net E class. So we write here net E dot NN module, which have our first init, and then we call our super to initialize our super class. Then we have make here sequential, which have here first here we have a linear fraction that is growing from 12 to 1. Then we have here sigmoid function, which means that it's an binary classification problem. Okay, then we have here def forward, that is taking from self to x, and it returns the whole sequential layer. Okay, sequential layer. Then we initialize our model class, then our loss as our BC BC loss, okay, binary cross entropy loss. Then we have our optimizer as our optim dot atom, okay, and we first passed our model dot parameters, and then our learning rate, which is equal to 0.001. If you run it, the run was successful and it is done, okay. Now we have our F class, okay. We write here class net F, which take our NN module. Then we make our init, which will take our self. Then we call our super init class. Then we make a sequential layer, NN dot sequential that is going from linear 12 to 1, no sigmoid. So here we make our forward, and I will return the sequential layer directly, okay. Return self dot sequential x. Then I initialize my model, name netf. Then we initialize my loss function, which is my binary cross entropy with logits loss, okay, with logits loss. And finally we have here optimizer as optim dot atom. We will pass here our model parameters, with learning rate equals to 0.0003, okay. And then with this our netf will also be ready, okay. Then we have our next as our netg. So we write here class netg, and everything as it is. Our first init, which will take our self here. Then we call our super init class. Then here we make our sequential layer. So we write sequential NN dot sequential. We have here first linear from 20 to 10. Then we have our leaky value with our 0.1 multiplication of -1 here for our leaky value. Then we have about 10 to 1, okay. It will be an, it is completing with our 1, okay, but here it's an binary classification problem, okay. Forward, which will end our self and x, and here we return our whole sequential layer. Here I will initialize my model netg. Then I initialize my loss, which is my BC, binary cross entropy loss with logits loss, and then my optimizer, which is my optim dot rms propagation. First our model parameters, and then our learning rate, which is equals to 0.001. Finally, when we run it, it runs perfectly. Okay, now we have our multi-class classification. So we make our class net_h, which will take our nn module, then our init class that takes our self, then calling this super constructor. Then we have here one layer only, two layer. So we write it as, so we use your sequential layer only, sh.sequential we write here linear, that is going from 30 to 10. Then in soft max with dimension equals to 1. Okay, then we make our forward function that takes our self and x, and we return our sequential layer. Okay, self dot sequential layer as it is. Okay, in our model we write our class name net_h. In our loss we write it nh.cross entropy loss, and then in our optimizer we have optim.sgd. We first passed our model parameters, and then our learning rate, which is equals to 0.05. When we will print it, we see that since there is no error, it works successfully. Okay, now we have our multi-class classification of our net I. Okay, so we write it normally net I, which take my nn module, have our init here, which take our self, then we initialize our super class, then we make here our sequential layer, sequential sequential layer, which takes here first linear from 16 to 64, and then dot ReLU, then my linear from 64 to 5. Then we have here def forward, which will be taking self and x, and I will be returning the whole sequential layer here. Then I initialize my model, then I initialize my loss, which is cross entropy loss for our multi-class classification. Then I have here optimizer as optim.adam. I pass my model parameters, PRA parameters, with learning rate equals to 0.001. When I run this, you will see that only one error is coming, name x is not defined. Okay, here no x. So finally it's done here. Okay, now we have here multi-class classification with our J column. Okay, so we write here as class J nn dot module we have our first init which take our super init. Then I made here my sequential layer, so we write here self dot sequential, which will first pass through our linear layer, that is 50 to 30. Then my tanh function, then my linear function that is going from 30 to 10. Okay, def forward we will be taking our self and x, and then we will be returning our sequential layer, self dot sequential layer x. Here we pass my initialize my model as j. We then initialize our loss function as nn dot cross entropy loss, then we have our optimizer equals to optim dot sgd with learning rate equals to 0.01 and momentum equals to 0.9. Here we also pass my model dot parameters. Okay, when we will run it, we will finally see there's an error here named sequential. Wait, I think it's name or sequential. It should be sequential now. So finally it's work perfectly and it is fine. Okay, so take the other question as homework, and that's all for today. And I hope you will complete the whole practice sheet of this day 5. Okay, so that's all for today. Thank you and bye bye.